Good afternoon, everyone. Thanks for joining the session. Today, the topic of the webinar is the innovative solutions to the current challenges of design and engineering the plastic components. Okay, and to give an introduction, I would like to start with DEP. DEP stands for Detroit Engineering Products. We were founded in 1998, and we are the creator of the Meshworks platform. DEP has an in-house R&D and also global CAE houses at different locations. Our headquarters is in Troy, Michigan, and we have our distributors in different locations across the globe. When we talk about the different verticals of our offering, we have an engineering consulting group, we have a software development solutions team, we do have a product development followed by talent acquisition. Now coming to the DEP team, we have our headquarters in Troy, Michigan, where we have like 160 plus employees, and we also have our office in California and Brazil. We have our office in 3 locations in India, in Chennai, Bangalore, and Pune, and we do have our office in different locations like Europe, China, Korea, and Japan. And DEP has a team of 500 plus engineers globally, and out of which 20% is PhDs, 70% were masters, and 10% were bachelors of engineering. Now, I would like to give a quick introduction to our Meshworks 2021. Meshworks 2021 is a rapid FE and CFD model creator, which has the intelligent parametric CA model building capability. Thereby, when you work with Meshworks, you can create quick design iterations and DOE studies. And with Meshworks morphing technology, you can get upfront design solution with the CAE and CAD models. And the morphing technology from Meshworks helps to reduce the CAE to CAD and CAD to CAE kind of interactive times. And a lot of design solutions can be achieved upfront in the initial phase itself. Next is our design optimization capability. Meshworks offers a powerful package, which is powered by the parameterization, morphing, and other tools. These all applications can be done in one model, and that can get converted into different solid environments. For example, if you create your DOE and MDO studies in your NVH model, the same can be nicely transformed into a crash or durability or CFD models with a very quick time. You don't have to repeat the process of recreating all the parameters. Next is a process automation capability. As we speak, many of our customers are currently using Meshworks for the repetitive applications by creating process automation with which they are able to save a lot of time in their day-to-day activities. And Meshworks pre and post-processing capabilities, when you look at it, it comes with a lot of powerful machine tools and automated tools for the assembly process and also the result exploration. On top of this, when you mesh in Meshworks, the models have the capability to become automatically parametric, and a lot of morphing and other features will make the use of a legacy model as a start point, and you can quickly achieve a lot of design changes in addition to the mesh models which we start with. Next is our concept tools. Conceptworks is our latest release. I would say like last couple of years back we released it, and it helps in a lot of architectural studies and conceptual studies on both structures and also for plastics. So we have 2 different modules on Conceptworks. One is for the structural applications for the metals, and other one is for plastics. Now coming into the Meshworks applications in the different stages of product development. Here is a typical cycle of the design getting matured all the way up to a final product. If you look at this in the conceptual stage, Meshworks modules like the morphing and concept packages will help you to quickly convert the FE models into new designs without any CAD in the middle of the process. Parameterization on all these concept models will enable you to perform the DOE optimization studies, which will help you to achieve a 90% frozen design in the conceptual stage itself. Next, when it comes into the detailed study where the CAD to FE changes the user can make, and the design will pretty much have very little amount of effort to be done in the detailed phase. In fact, when you go to the final virtual validation phases and the maintenance phases, you will have very little design changes might be required to meet your targets. So each of these areas, for example, concept phase, if you look at it, we will be using our meshing, morphing and concept modules in Meshworks. When it comes to the detailed phase of studies, the parametric CAE and topology optimization modules will play a major role. And the next steps of the validation maintenance, you can see like the quick meshing and modeling assembly tools helping to accelerate the product development cycle. Next, I would like to quickly touch upon what Meshworks can do. Meshworks can quickly build FE models for all the assemblies. Lot of OEMs as we speak are currently using Meshworks for their full vehicle model building. And we can build all the sub-assemblies in the vehicle and in fact full vehicle model building with all the run checks with the help of Meshworks. And you have a lot of customized modules for different assemblies to get automatically meshed and assembled and set up with load cases. So in this webinar, we will be covering mainly our applications on the plastic industries. So I would let Aditya to take it forward. Go ahead, Aditya.
Okay. So, thank you, Raj, for the introduction. So let me carry on with some of the demonstrations for today. So as we can see, Meshworks is currently being used in a lot of applications, like plastic parts. And we will now address how we can assign the Meshworks software for such complex parts. As you can see, parts in front of you, how we can mesh the components, and then we can assign some of the variable thickness to the components. So we will also be demonstrating how we are going to create some shell ribs as cross shell ribs and also as parameters. So in some of the following demonstrations, and we will also see how Meshworks will help to compare information, from wrap analysis and no buckling or no undercuts with some of the baseline CAD parts. So let me jump right into the demonstration for today. So as you can see, we have a very complex plastic geometry. So we have intricate parts such as your dog houses, your clip towers, and some complex rib regions. And we will see how we can use Meshworks to quickly create a mid-plane mesh by using our auto mid-plane mesh function. So once we have imported the model, we will go into basic mesh. So under basic mesh, we will select the auto midplane mesh, and then we will select the surface. So once the surface is selected, the user can go ahead and give some of the advanced inputs. These advanced inputs, the user can set the parameters for your target element size, your minimum element size, your max element size, all your caudal angles, etc. So once the user is satisfied, the user can simply go ahead and click on execute. So when the process executes, it will identify the midplane pass, and then it will generate the mesh. And then once the mesh is generated for all the identified features, it will join the patches, and then it will remesh with respect to the parameters that the user has set, and then it will go ahead and move the surface to the midplane automatically. So all this is done behind the scenes, where the user doesn't have to put any manual intervention, and everything is done automatically. So you can see that it's identified the midplane pass and also created the midplane mesh. So this is how the output will be. Let me put it in a wireframe. So you can see how quickly one can obtain a mid-plane mesh with little to no effort. So once the user is satisfied with the output, the user can perform variable or various tasks or functions, such as your remesh function, or if you want to eliminate some of the trias, which is the mesh editing function that is available using Meshworks, or also quality correction functions. So all these are housed under one roof under the Meshworks software. So as you can see how well the output, we have got the output. So as the first function, we will see how we can remesh a surface. So let me go into one particular section. Just say if you want to remesh this particular region under basic mesh, we have something called the remesher, where we can select the desired surface, and then the user can also discretize the surface with respect to the node. By doing that, you can see how well the remesh is being done. So just say if you want to equivalence the nodes at midpoint, it's as simple as just going to the replace nodes function and equivalencing the nodes. So let me carry out the same function in another region by just discretizing the nodes. So I select the nodes and simply click on remesh. So with respect to the nodes that you're selecting, you are able to get a very neat output. So this can be done in pretty much any surface that the user selects. So now let's see how the user can eliminate some of the trias very quickly. So we have something called the mesh editing function. So we go to mesh editing and we have the move tria option, where the user can simply just select the trias and it will show a path with which the user can move the trias. And if the user can find an opposite trias, you can simply just eliminate those trias, like how I showed you right now. So similarly, I will show it you in another region. So it's as simple as just clicking and moving the trias and eliminating the trias. So I will select another region where I will just move the tria to the end and simply eliminate the existing tria on your mesh. So once you're done with this, the user will always look into correcting the quality. So we have something called the auto quality correction, as in where we go into the quality function, and then the user simply has to select or display the elements. As you can see, it shows the number of failed elements to the left top corner of the canvas. So you can see there are close to 235 failed elements. So simply just go ahead and select, drag and select, and click on execute. So very quickly, it will automatically go ahead and correct some of the failed elements. As you can see, almost 50% of the failed elements has been quality corrected with just a click of a button. And there are some quality that can be corrected manually. And also, if you can run it multiple times, you can correct your quality automatically. So next will be the assign nodal thickness function, wherein the user can very easily assign the nodal thickness. So we just select the element and then select the surface by displayed. And then I will go by with assigning it by the incremental value. And then I'll click on calculate min and max. What it will do is it will calculate the minimum and the maximum value automatically. So you can see that it's calculated the value. And we can also change the incremental value. So I'm just going to give 0.2 and click on regroup. So the output is instantaneous. You can see very easily the Meshworks software has automatically assigned the nodal thickness to the component individually with respect to the features that it's identified. So it not only identifies the features. When I refresh the model tree, you can see that the property cards have also been created automatically. So this is a highly efficient method where you can even select multiple components and then assign your nodal thickness. So moving on to the next one, we will see how one can create a rib parameter on a plastic component. So for this, you can see we have a complex region. The only prerequisite is to create a 1D line, which will act as a trajectory. So I will go into the create shell rib parameter function, where I will select my base component. And then once I've selected my base component, I will have to define a plane. So along which my shell ribs will be created. So I will specify 3 nodes by picking 3 nodes in along the direction that I want my shell to be created. And then I specify the node and click on return. You can see a reference line has been created. And our next input will be to select the trajectory line, which is the 1D mesh that we have created. So once I've selected the trajectory line, I'll simply click on sketch the rib, which will give me the side profile of the reference nodes that we have selected. So I have selected 4 points, which will denote the profile of the shell rib. So once the user is satisfied, simply just click on preview. So you can see we just click a few buttons, we are able to create the rib. So once the user is satisfied, just click on accept. And then the next step is to create the parameter itself. So you can either execute it as a parameter or create it as a one-time setting. So I'm just going with execute as a parameter. So I will go by trajectory and I will select my trajectory. So once I've selected the trajectory, which is again a very simple 1D line that we have created, I will select the component and then I'll specify the pitch, which will act as a distance. So the distance between the number of ribs that we are going to create. So just say I will go with max of 5 ribs and I've given a current of 5 ribs. So it will display 5 shell ribs that it's going to create. So you can see very quickly along the trajectory line that we have selected, we are able to very quickly create multiple shell ribs. So I'm just going to go with 10 shell ribs and then click on preview. So you can see in just a click of a button, we are able to generate 10 shell ribs with very few minimal inputs. So once you can set the parameter name, click on save and click on return, and you can review your parameter that you've just created. So I just have to link the parameter and click on preview. Just say I want to review 8 shell ribs. So you can see the parameter has been created in just less than few minutes. So the next demo that we'll be seeing is how we can create cross ribs as a one-time execution. So we will go into the create shell rib function, where I will first define my plane. So as it's a cross rib that I'm going to create, I will select my plane in a crossed manner. So you can see that the plane has been created. So I'll simply click on return, where it creates a reference line. And the next input will be the reference node. So this reference node will be the point A to point B, where I'm going to sketch my profile. So we can click on sketch profile, which will show us the side profile of the reference line that we have just generated, where I ballpark and draw the profile of the rib that I'm going to generate. So once I'm satisfied, I'll simply just click on accept, where the user will also have the power to modify the profile. So for now, I'm satisfied with this. So I'm just clicking on accept and click on preview. So I can also change the parameter for the element size, but I'm just sticking to 2 mm. So you can see very quickly, I'm able to create a cross rib with very little manual effort. So just say if I want to create an additional cross rib, to strengthen my component. So I will follow the same procedure where I will specify my line, the reference line, and then I will select my reference nodes from point A to point B. So it can be either way, and click on sketch the rib, and again it will show me the site profile where the user can simply click on the canvas and create the geometry and click on accept. So once the profile has been done, simply go ahead and click on preview. And once you're satisfied with the output, just simply click on execute. So you can see how very less inputs is required to create such complex regions. So I will go ahead and quickly show you exactly how a user can create a honeycomb stiffener in Meshworks. So in front of us, we have a plastic component. Now, whenever a user has to create an honeycomb stiffener, a user just has to select the elements where he wants to create it. Then he has to define the vector. The vector is nothing but the height. Now, after specifying the height of the stiffener, then user has to define the number of rows and number of column for each stiffener and also the diameter. So once everything is been specified and when a user clicks on preview, automatically Meshworks very nicely shows the preview of the honeycomb stiffener and the pattern. A user then can pan it as per his convenience on the model. He can also rotate it, as we can see on the screen. And when we look like this is the ideal position of the honeycomb stiffener, then we click on accept. So the accept will nothing but it will just imprint onto the mesh. And once the next step has been selected, that is called as an execute, automatically a honeycomb stiffener has been created in mesh on the mesh level, and there is a very nice node-to-node connection between the stiffener which is created and the base element. So a user can import his own patterns, his own images, and then he can just create very nice stiffeners in the mesh. So the next is Conceptworks Plastics. So we have a very nice tool in Meshworks that is called as an Conceptworks Plastic. So in this, we in front of us we have a plastic component, CAD component, and then this is a GUI where we can nicely create the Conceptworks Plastics. So by just few clicks, we can create some special features like hit stick, locator, clips, clip tower, doghouses, locator pin, and etc. So we will see one by one in this particular demo. So the first one is a hit stick. So in this hit stick, what a user has to do is he has to select the point where he wants to create a hit stick, then the CAD surface and the vector. As soon as he clicks on preview, a hit stick has been generated. Now what if I have to change the diameters? Let's say my diameter is 8, height is 25, and then rib count is instead of 4, I need 5, and click on preview. So automatically the hit stick gets updated, and then this is how the preview will look like. We have also given an adjust tool where as soon as we click on adjust, a user can very nicely go ahead and do modifications on the hit stick. Let's say if I have to translate it, a user has to define the height and then simply click on translate. The hit stick will move with the 5 mm as we can see on the screen. Now if a user has to rotate the model or rotate the heat stick, then he can do that too with a 5-degree angle as we can see on the screen. Now this is not connected to the base component because we haven't clicked on accept. So as soon as we click on accept, very nicely it has nicely stitched with the base CAD surface. Now similarly, we have seen the heat stick. Now we will see how we can create a locator. Again, the process is pretty simple. Select a screen point, CAD surface, vector, and then by giving the inputs, when we click on preview, automatically a locator has been created. Now again, we have an adjust button to this particular tool too, but for time, we haven't shown any additional changes on it. Now, what if I have to create a clip? So just define the 2 points of the length, CAD surface, a vector for the height for the clip, and with respect to the width and the height, a clip has been created on a CAD surface. This is how pretty quick and easy a user can create multiple CAD surfaces or CAD features onto the plastic component. As we can see, a clip has been created. I-section clip has been created in Meshworks. Now we will see a clip tower. Again, the process is same. Select the 2 points for the length, CAD surface, the height, and then by using the input, whatever we have given on the screen, a nice clip has been created onto the CAD surface. If a user wants to create intermediate ribs, he can do that too by just checking on the create center ribs. And once you click on accept, automatically it is nicely attached to the base surface. So the next is Locator. Now we will see how we can create a locator onto a CAD surface. So just give the CAD surface, screen input, vector, and then simply click on preview. So by the information which we have inserted, a nice locator has been created. And then once we click on accept, it has attached to the base CAD surface with a nice yellow edge on it. Now the next is Doghouse. So a user can create a Doghouse to define the length, define the CAD surface, define the height, and click on preview. A nice Doghouse has been created with the length of 20 and height of 10. Now what if I have to change the lateral face? I have to give a draft angle of 5 degrees. A user can do that too. If he wants to give on the back face, he can do that too by just giving the angle, click on preview. That's all. Now we have also given the fillet radius, as we can see on the screen, that is 2. So I'll just change it to 1, and as soon as I click on accept, a nice fillet has been created onto the CAD surface and then imprinted onto the base surface, as we can see on the screen. So this were the main single features. Now we will go forward to multi features, where what if I want to create a doghouse, and on the doghouse if I have to create a locator. Again, the process is same, just select 2 points for the length of the doghouse. This is how it is created with the fillet radius as 1. A doghouse is created, inserted onto the base surface. And now what if I have to create a locator? So just select a point on the locator's face, CAD surface, and then click on preview. Automatically a locator has been created on the screen. Now the next is doghouse with locator. Oh, I'm sorry, doghouse with I-section on the doghouse. So first we will be going ahead and creating a doghouse. So that's what we are going to do here is, now we can change the, we can flip it along the width so that it will not intersect with the component. Just click on accept with a 2 mm of fillet radius. And now we will be creating an I-section onto the doghouse. So select 2 points. This is so simple that a user can create it on his plastic component very quickly and very efficiently. And I-section clip has been created and inserted onto the doghouse, as we can see on the screen. So this is how we can create. Now let's go ahead and see the rib creations. So there are different ways to create a rib, that is direct offset method, trim method, edge rib creation, and etc. So direct offset method is nothing but it will very nicely identify the base component, and with respect to the base component, it will go ahead and create a rib. So that's what the offset is. So here we have to define the CAD surface, then we have to define the vector, then we have to define the screen point exactly where we want the rib, that's the center point. And as soon as we click on create rib, a rib has been created with an offset of 5 mm. Let's say I have to create now with the trim method. The process is also pretty simple. Again, select the CAD surfaces, define the vector in which direction we want the ribs to be created, and then simply click on preview the ribs. Now let's say if you want to trim the points, yes, you can do that too by just clicking on the clicking 2 points on the rib, and then you can very nicely go ahead and do the trimming points, and then you can just trim the cat's ribs. Now the next is edge rib. What if we need to create some cross ribs? As how we can see, we have seen on the element level, we can similarly do it on a CAD level too. So user just has to select 2 edges of the CAD and simply click on execute. It will very nicely create a rib, and also it will insert it on the base surface. Similarly, what if I have to create like a cross rib again, but there is another CAD surface inside which will intersect? We don't have to worry about it. Meshworks will automatically take care of it by just clicking on execute. It will identify the mid rib, and then it will stitch it automatically. Then we have a point method, and we also have the sketch method. So in point method, a user has to just define the CAD surface, CAD curves, and then by using the CAD curve, on the screen, a user has to define the boundary points. Just go a little bit forward. Yep, that's how we can create the curves. Screen point, that is nothing but the start point, base surface, and then define the vector, and a rib has been created in that particular location. Yeah. Similarly, I'll show you now the sketch rib. So in the sketch rib too, we can very nicely go ahead and do the sketching. The user has to define the point, then define a plane, define the start point and end point of the rib. Simply, it very nicely creates a big plane CAD surface. Now you can sketch on the CAD surface, as we can see, and then once you click on preview rib, automatically it will delete the rest of the CAD surface, and it will just create a rib, nice CAD rib for you. So this is how quickly and efficiently we can create multiple CAD features onto the plastic component. And once we create the complete features as per our requirement, we can go for meshing. So the next step is to do the meshing. So user has to define the CAD surfaces and simply click on preview. So automatically Meshworks will go ahead and do the meshing for it. And then this is nothing but the thickness visualization. So it is just a visualization where it will show that thickness of the CAD surface is nothing but 1.2, which has been created in the background whenever we have been giving the draft angle. So it automatically creates the property in the background. So this just saves a lot of time in the background. So this was all about the Conceptworks Plastic. Now let's move forward with the impulse deformation for wattage. So this shows how Meshworks helps to compare the information from the warp analysis. Now for this, I will go for a live demo. So just to show you that we have a CAD component in front of us. Show you the CAD component. Now this is nothing but a plastic component. So this plastic component is having a thickness, as we can see here, and it has a varying thickness all over the places. Has some special features which we can see on the screen. Now what I will show you is we have the base mesh. So the base mesh is nothing but the 2D surface, the 2D mesh. So this 2D mesh is very nicely exactly sitting at the center or the mid plane of the CAD surface, as we can see on the screen. I'll show you a few other locations. You can see here, wherein we can see the 2D mesh is exactly sitting at the center or the mid plane location of the CAD surface.
I will go ahead and hide the CAD too so that you can see the mesh. Now, what if, so in front of us, we have a baseline CAD. So this is our baseline CAD, and then this is our baseline mesh. And also we have a warp mesh, which we got it from the warp analysis. As we can see, there is some deformation here. There is some deformation on this side too. And now in Meshworks, we have a very nice tool by using the baseline CAD and baseline mesh and the warped mesh. We can very nicely go ahead and create a warped CAD. So to do that, I'll quickly show you the live demo for this. It is called as an impose deformation, where I have to select the CAD. I have to select the undeformed FE file, that is the baseline model. Deformed FE file, that is nothing but the warped model, and simply click on impose. So automatically Meshworks will identify the, with respect to the NURBS equation, it will identify the end-to-end points, and then it will create a warped CAD for us. So the deformation has been done. I will quickly go ahead and show you the initial CAD. So if we can see here, there is a change which has happened between the initial CAD and the warped CAD. Now I will quickly show you the nominal mesh. So this nominal mesh is exactly sitting where it was sitting on the initial CAD. And now I will show you the warped mesh. So now this warped mesh has also been sitting on the new CAD, which has been generated in Meshworks by giving just 3 inputs. So this is how quickly and efficiently we can do a comparison between the warped analysis model, and then we can generate new different CAD models in Meshworks. So to do this, to complete this process manually, it takes around 32 hours. But by using our CAD mod for Meshworks tools, we can just finish this entire 9 yards in just 2 hours. Now, the takeaway message here is Meshworks as a CE platform is a tool where it can nicely create the mid-plane mesh for all the plastic components, no matter which industry it is. Meshworks as a CE platform is geared to handle complex geometries for several industries. The design enablers in Meshworks helps create ribs and manage features without waiting for CAD. So this way it accelerates what if scenario investigation.